afternoon. After that very interesting topic about climate change and to see how the Earth is changing, maybe it's good to think about Plan B. So my question for you is, have you ever thought about other planets and if there is life on those planets? So that's a question that we're trying to answer at this research group at NASA Ames. And I think that we also are motivated by the fact that this has been a mankind question. Like many people have wondered about this. And the first I want to think about this was Epicurus, more than 2,000 years ago, and he got it right. There are infinite numbers of worlds, some of them like us and some of them different. And that's pretty impressive. He didn't even have a computer, and he figured it out right. So then science fiction took over, and they went all over the board with all kind of different characters. I like Lost in Space down there. And now with Star Wars coming up, at the end of the day, sometimes we forget that this is all about exoplanets. However, this became real 20 years ago when a couple of Swiss astronomers, they found the first exoplanet around a star nearby, and it was a Jupiter-like planet. So that planet kind of changed and became a reality. After that, there has been a long series of discoveries. There is a plethora of planets. And we know that 1 every 2 stars, they have a terrestrial planet, which is huge because there are billions of planets then on the galaxy. That makes infinite possibility for life. This is a portrait of how those planets, we picture those planets, because we cannot see them, but we imagine them like that. And there are like thousands of planets. We have discovered more than 5,000 planet candidates. And the field is evolving very fast. So the interesting part is what we see from the data is on the left. It's just a signal. We don't see a planet. And then what the artists make is what you see on the right and come out published in the newspapers. So what we're going after is to find a planet like us, but to really see the planet. What you see on top is the data from Kepler spacecraft, which is just a light curve, but you don't see a planet. You see that points. Then what we're trying to do is to see the actual Earth. That's going to be like a pixelated image. And that's really hard. Why it's hard is because it's very faint. You see the Earth here seen from Cassini, and Saturn is used as a coronagraph to block the light of the sun. If you don't have Saturn on the way, then you won't be able to see a planet. And this is within the solar system. Now, when you go to our stellar backyard, all those stars there are visible naked eye, but the closest star is Alpha Centauri, which is within that square box inside. So that's our target because it's so close that you can see it with a 30-centimeter telescope. You don't need a huge telescope. Actually, I called my nephew and I say, hey, can you take a picture? He went with a point and shoot. He got this picture, and here it is. Oh, that's pretty amazing. You cannot do that with every science case around. So look, it's fantastic with moon and clouds. Now, if you take the most powerful telescope in the world and then you put the zoom on it, that's what you see. There are 2 stars. So basically, you get 2 targets for the price of 1 because you're aiming at the target and you can switch back and forth. And then makes this target very compelling. So then I was working on this collapsible space telescope to put it on a CubeSat. And then I say, why we cannot fly this guy and put some technology in it and to be able to suppress the light of the star and try to see a planet? It's going to be low cost. And then I said, okay, the recipe is 12-inch telescope, 30-centimeter amateur, a small satellite, and a right share on a rocket, because you don't have to pay the whole rocket. You can just so it turns out that then you have to add a lot of technology and a lot of work, and this is what we do at NASA. It's very hard because you need to suppress the light of the star that is 10 billion times brighter than the planet. But that's the reason that we spend all day and night there. And after we do it, then we can see a planet. So the plan is to build this, pack all that technology on a small package, then put it on a spacecraft off the shelf, put it on a rideshare on this side connection, and orbit, low Earth orbit for 2 years until we see that. That's what we want to see. That's a simulation. If you put an Earth-like planet around Alpha Centauri, that's our expected result. This E is the Earth. So imagine the impact. I always wonder, my motivation for this is, imagine you were be part of the Apollo mission, or during that time, I don't know, maybe some people remember, I was not here, and imagine how cool it would have been to follow a discovery of that magnitude. So I think that this is something that everybody should be part, and everybody should kind of follow and try to make it happen together, because it's relevant for everybody. So that's what I wanted to share with you guys. Thank you very much.